And dear friends, with massive 3.3 billion parameters, it demonstrates state-of-the-art performance, achieving an FID score of 8.03 on Coco 30K dataset, one of the best among open source models. And towards the study found that 74% of models scored below 0.5 in overall performance, indicating that there is still room for improvement, whether it's improving text image coherence, reducing cost, or accelerating inference. Each innovation contributes to making text to image models more powerful, efficient, and accessible. Since standard backpropagation would require massive memory resources, AlignProp cleverly uses low rank adapter weight modules and gradient checkpointing to reduce memory consumption while still achieving high performance. The third one, high informative data, that is using a large vision language model to automatically generate dense pseudo captions, improving text to image alignment. Unlike traditional distillation method, which involve a two-stage training process, that is distillation plus fine-tuning. So this approach combines both into a single stage, significantly simplifying the training pipeline. Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, the field of AI-generated images has seen remarkable advancement, moving from early rudimentary design to today's near photorealistic output. Diffusion models have played a key role in this transformation, offering significant improvements in quality, realism, and efficiency. However, challenges like computational cost, text-image alignment, and controllability still remain. Dear friends, in this session, we will explore 5 groundbreaking research papers that tackle these issues and push the boundaries of text-to-image generation. The first paper, it is on Kandinsky and improved text-to-image synthesis with image, prior, and latent diffusion. Dear friends, this Kandinsky model is a major leap forward in text-to-image generation, combining the strengths of image prior model with the latent diffusion techniques. Unlike traditional approaches that either generate images pixel by pixel or in a latent space, Kandinsky introduced a novel mechanism where an image prior model is trained separately to map text embedded to image embeddings using clip. One of its standout feature is the modified MOVQ, that is multi-objective vector quantization implementation, so which act as an advanced image autoencoder. So this allows Kandinsky to generate high quality images while keeping computational costs manageable. And dear friends, with massive 3.3 billion parameters, it demonstrates state-of-the-art performance, achieving an FID score of 8.03 on Coco 30K dataset, one of the best among open source models. Additionally, Kandinsky supports multiple generative tasks, including text-to-image synthesis, image fusion, text-image fusion, image variation, and in-painting or out-painting, making it a high versatile tool in AI-generated content creation. The next paper, it is aligning text-to-image diffusion model with reward backpropagation. Dear friends, one of the biggest challenges with text-to-image models is that they are often trained unsupervised, making it difficult to align them with human preferences, such as aesthetic quality, realism, and semantic alignment. To address this, the paper introduced ImagenHub, a novel approach that fine-tunes diffusion model using reward backpropagation. Traditional fine-tuning methods rely on reinforcement learning, which is notorious for its high variance in gradient estimation, making optimization unstable. ImagenHub, on the other hand, propagates reward gradients directly through the denoising process, enabling better control over image generation. Since standard backpropagation would require massive memory resources, Align Prop cleverly uses low rank adapter weight modules and gradient checkpointing to reduce memory consumption while still achieving high performance. The results shows that the Align Prompt, of course, dear friends, this optimizes text to image models faster and more effectively than existing method, making it a game changer for improving image text semantic alignment, aesthetic object controllability, and other fine-grained properties. Next paper, PixArt-α. So fast training of diffusion transformer for photorealistic text to image synthesis. Different training high quality text to image model is an expensive and time consuming process, often requiring millions of GPU hours. PixArt-α aims to significantly reduce training costs while maintaining high image quality, making it a breakthrough for startups and AI researchers. To achieve this, PixArt-α introduced three key innovations. A training strategy decomposition, that is breaking down training into three distinct steps to optimize pixel dependency, text image alignment, and aesthetics separately. Next, efficient T2I transformer, that is incorporating cross attention model into the diffusion transformer, that is DIT, to reduce computational overhead. The third one, high informative data, that is using a large vision language model to automatically generate dense pseudo captions, improving text to image alignment. Difference to the innovation, PixArt-α achieves state-of-the-art performance at just 10.8% of the training cost of stable diffusion v1.5 version and massive reduction in energy and computational expense. Not only does this save nearly $300,000 in infrastructure cost, but it also cuts CO2 emissions by 90%, making it an eco-friendly approach to generative AI. Next, it is CODI, that is Conditional Diffusion Distillation for higher fidelity and faster image generation. Different diffusion models are known for their slow sampling time, which can make them impractical for real-time applications like image editing, restoration, and super resolution. This paper introduced conditional diffusion distillation, a technique that drastically speeds up the sampling process while maintaining high-quality outputs. Unlike traditional distillation method, which involve a two-stage training process, that is distillation plus fine-tuning. So this approach combines both into a single stage, significantly simplifying the training pipeline. Additionally, it introduced a parameter efficient mechanism allowing each conditional generation task, that is super resolution or in painting. Okay, that would be an example, and to use only a few additional parameters instead of retraining entire model. And towards the result, of course, it shows that this method can match or even outperform fine-tuned diffusion model while reducing inference time significantly, making it a promising solution for AI-powered creative applications. Okay, today's last paper, ImagenHub, standardizing the evaluation of conditional image generation model. Difference with the rapid development of text to image and image editing models, it has been increasingly difficult to compare their performance fairly. Different models are tested on different datasets, use different evaluation metrics, and have varying inference setting, making it nearly impossible to conduct objective comparison. To solve this, ImagenHub introduced a standardized framework for benchmarking conditional image generation model. It defines 7 major tasks, curates high quality data sets for evaluation, and establishes an unified inference pipeline to ensure fair comparison across models. Additionally, ImagenHub incorporates human evaluation scores like semantic consistency and perceptual quality with trained expert rather following strict evaluation guidelines. And towards the study found that 74% of models scored below 0.5 in overall performance, indicating that there is still room for improvement. And 83% of claims made in research papers were valid, but some did not hold up under Imagen's rigorous testing. So no existing automatic metrics correlated well with human evaluation, except for subject-driven image generation. By setting a new benchmark for evaluating generative models, this ImagenHub helps researchers and developers objectively measure their progress and build better, more reliable AI models. Dear friends, from enhancing image quality and optimizing training efficiency to aligning models with human preference and standardizing evaluation model, these 5 research papers mark significant progress in AI-generated imagery. Whether it's improving text-image coherence, reducing cost, or accelerating inference, each innovation contributes to making text-to-image models more powerful, efficient, and accessible. As AI continues to evolve, these advancements will shape the future of creative content generations, artistic expression, and commercial AI application. Of course, as usual, which of these breakthroughs excites you the most? Let us know in the comments. And don't forget to like and subscribe for more cutting-edge AI research updates. Thanks for watching. Happy learning, dear friends.